Name is Rohit Manish, and our point is cardiovascular disease detection, and our teammates are Erra Maidar and Kodada Anish Kumar Reddy. And this is the contents we are covering. And when it comes to introduction, the cardiovascular disease detection point utilizes machine learning techniques to predict the likelihood of cardiovascular diseases. And so that we are using support vector machine, KNN, decision trees, logic regression, random forest, and also XGBoost. And these are the traditional algorithms that we are using. And the motivation behind choosing the topic is cardiovascular diseases are the leading cause of global deaths. So, the existing diagnostic methods are costly and not accessible everywhere. So, this is the motivation behind choosing the topic. And the problem statement is same as the motivation. And the objective is to develop a ML model for early and reliable CVD detection, compare algorithms like SVM, KNN, decision trees, logistic regression, and random forest, and to assist healthcare providers with a smart decision support system. And the project aims to solve or improve. The project aims to solve the limitations of traditional cardiovascular disease diagnostic methods. This is the project aim. And when it comes to the existing system, there are the traditional approaches like electrocardiogram (ECG) and magnetic resonance imaging (MRI), CT scans, and angiography, which are commonly used to detect cardiovascular diseases. So the limitations are the main thing is cost. So many people will not choose this because of the cost. And these are the inspirations that we took from and the proposed system. The proposed system utilizes machine learning models trained on medical dataset to predict diseases accurately. The models employed include support vector machine, KNN, decision logistic regression, random forest, and XGBoost. Among these, random forest and XGBoost show the best performance with an accuracy of approximately 74%. And and this is the system architecture, and this is this is the data process model where the raw data will undergo data cleaning, which include encoding and handling outliers, and then it will go to feature engine, and then followed by correlation analysis, feature selection, data splitting, and finally the processed data will be sent to the data model. And these are the algorithms that we use, which is decision tree classifier, k-nearest neighbors, logistic regression, random forest, support vector machine, XGBoost. And the implementation details are we almost calculate 70,000 patient instances and with 13 attributes which are called from medical datasets stored in structured tabular format CSV, which is used for processing. And as we said before, the data processing includes handling missing values, outliers, and categorical encoding. And we upload feature scaling, and also we use SLK based for feature selection. Mm, is about it. And when it comes to testing and validation, we conducted unit testing for data preprocessing, integration testing for model deployment, and performance testing on predictions using scikit learning and PyTest. Mm, and we verify data cleaning accuracy, feature selection, impact, and model predictions, ensuring XGBoost maintains 94% accuracy across different datasets. This is everything. And the validation metrics we used are F1 score, precision, accuracy, off-prop with random forest and XGBoost, outperforming other classifiers. And these are the results we achieved 74% accuracy with random forest and XGBoost. Visualized using conclusion matrices, precision recall curves, and ASC ROC graphs for comparison. And this is the results and analysis table for everything. The decision tree came like 63% accuracy, and the precision is 0.63, and the recall is 0.63, and the fun score is 0.6313. And the k nearest neighbors accuracy is 71%, precision is 0.71, recall is 0.68, F1 score is 0.70. And logistic gives 73%, 0.73, 0.73, 0.73. And the random fault is also almost 74%, 0.74, 0.74, 0.74. And the SVM is 73.12, 0.7312, 0.71, 0.7182. XGBoost 74%, 0.7381, 0.74, 0.74. And this is the same performance comparison of machine learning models. And this is a chart. And the demonstration and this is the demonstration prototype showcase, and this is a visual demonstration. So I'll go with the model for the demonstration. This is our implemented model. These are the inputs that we use, which are panda, numpy, matplotlib, and seaborn. And this is the SVM libraries for the training the model like train test, split, standard scalar, SVC, select best, and all. And these are for decision tree and also the curves. And this is for XGB, and these are for KNN, and these are for logistic regression, and these are for random forest, and this just for for hot encoder, standard scalar, and everything. And when we came to this, uh, here we upload a CSV file, and just we displayed the first few rows of the dataset. You just ensure that, and then we check for the total data information and the data types. And these are the summary statistics where we use the count of ID and the mean of ID, standard of ID, and all the other attributes here. And here we check for the data. Here we did the data cleaning and also we check the missing values. And here we remove the outliers in this. And the plotting graphs for removal of outliers. This is the blood pressure distribution before cleaning, and this is the blood pressure distribution after cleaning. And for the sake of data preprocessing, we converted the age from days to years for data readability. And we calculated body mass index to remove the weight and height individual data sets. And the plotting, then this is for age years and BMI graph. And this is the scatter plot in age for age versus BMI. And this is the BMI distribution. And here we encode the categorical values using the one hot encoder. And this is the graph plotting for encoding categorical variables. Here this is for encoding categorical variables versus BMI. And this is the assigning target variables where ID, age, glucose, smoke, alcohol, active, cardio, takes place. These are the main target variables. And why the only result is for cardio, whether it is there or not, the heart disease. And graph plotting for relationship between variables. And this is the pair plot for selected features. What we already said about the selected features here. And this is box plot visualization. Here, look at this visualization. It is BMI distribution by cardiovascular disease presence. Correlation of each feature in dataset. This is the correlation heat map. And here it came diagonally. And this is the histograms of numerical features where like age, ID, gender, height, weight, APHI, high BP and low BP. And this is for count of cardiovascular disease cases. The number of yes cases are almost 33,000 and the number of no cases are 35,000. Split data here we started data modeling. Uh, we here splitted the train test data splits into train and both separate datasets. And this is for standardizing features and we select KPIs for feature selection. And we selected the target variables. And these are the selected features here. Wait, AP, and this is decision tree analysis. This one. And as you can see here, this is the complete evolution of decision tree, and the accuracy is 0.63. And this is the ROC curve for that. And this is the confusion matrix. And this is for accuracy. There look, you can see the accuracy is 0.63 and precision recall and reference score are 0.63 almost as well. And this is the classification report as we gave before. And this is when we use SGB for the decision tree, we boosted the accuracy at almost up to 0.74. And this is for the KNN, where we got accuracy 0.71. And this is the complete evaluation. And this is the ROC curves and precision recall curve. And this is the logistic regression, where the accuracy is almost 0.73. And this is the confusion matrix and the ROC curve. And this is the final random. Then this is the random forest, where the accuracy is almost 0.74 again. And this is the ROC curve and the precision recall curve are same. And this is the top 10 important features for this feature important spot. And this is the SVM analysis, where the accuracy is, and this is the feature important plot for SVM. The accuracy of SVM model is 0.73, which is almost 0.74. This is the user input design. Uh, We took the features and we used one algorithm and we gave the user inputs here, and using the user inputs when we gave the separate user inputs like and the numbering days and the gender and the height and the weight and everything, we'll get the result like you are predicted to not have cardiovascular disease, or you will get you predicted to have cardiovascular disease. And this is about the model implementation. So when we go back to our PPT, the demonstration is over. And this is the Sustainable Development Goals. The SDGs for our includes two, SDG 3 and SDG 9. And the challenges we encountered are facing data quality issues with missing values and outliers, model overfitting in complex algorithms, performance bottlenecks in large data processing. And these are the challenges we encountered. And the solutions we covered are applied data cleaning sets, use LKBS for that, which helps to reduce overfitting and optimize hyperparameters for better model performance. And these are the advantages, which are early detection, high accuracy, non-invasive, scalable, real-time predictions, cost-effective, user-friendly, and supports preventive care. And these are limitations and future scope, planned enhancements, develop a real-time cardiovascular prediction system with an intuitive web interface for user accessibility. This is for the future scope. And the potential research directions are investigate advanced deep learning models like transformations for time series health data analysis. And this is the YouTube demonstration video. And this is the publication status where the payment is completed. And these are the references as we used before. Thank you.